Hi there. Okay, so I'm hoping that you watched the Brain Pop video on the periodic table. It's really short and it covers everything really nicely, and it's a good refresher for what we're going to talk about today, which is the periodic table. Okay, so if we take a look at our own periodic table and we look at this kind of legend here, that's what we're going to fill in our notes. Okay. So the first number at the top here, right, we know that this is our atomic number. Right on. And the big symbol here, right, well, I just said that, it's the symbol. And the number underneath, which is normally the largest number, that's the atomic mass. And sometimes you see it called atomic weight. It's totally fine to use either one. Okay, and at the bottom we have the name. Okay, now elements on the periodic table are arranged in their order of atomic number. And the atomic number tells us the number of protons. So if you're like, Miss Labiuk, they're arranged by order of protons, yes, okay, which is also their atomic number, okay? So the atomic number tells us the number of protons in an atom, which also equals the number of electrons, okay? Now, the atomic mass, or the atomic weight, equals the number of neutrons and protons in the atom, or in the nucleus. Okay, right on. So in other words, okay, the number of neutrons equals the atomic mass minus the atomic number. Okay, so when I would take a little pen here and I'm gonna highlight that because that always seems to give everyone grief all the time. Okay, and we also put that on our periodic table here too, right? So we have it as a quick reference. This minus atomic number equals number of neutrons. Right on. Okay, turn the page. Okay, so next up, periods. What are periods? Okay, so the rows on a periodic table are called periods. Okay, the period number equals the number of energy levels or orbits or shells. Okay, elements in the same periods do not demonstrate similar properties as they do in families or columns. Okay, so take out your periodic table. Okay, so our periods are these things here. Okay, so each row is a period. So I'm going to write that over here. I'm going to go periods. Okay, and then I'm going to number my rows or number my periods. So I have 1, 2, 3, 4, 5, 6, and 7. Okay, so this will tell me if I'm looking at rubidium, I'm in the 5th period, which means rubidium has 5 shells. Okay, that's super important. Okay, now, what about families? Okay, so the vertical columns on the periodic table are called families or groups. Okay, families are numbered from 1 to 18 across the top of the table. So let's do that on our periodic table. Okay, I'm going to change my color here. Okay, so I'm going to write this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so those are the number of families on the periodic table, right? And everything that's in the same family or the same group all has very similar properties. Just like you and your own family, you have very similar properties to your parents and siblings and aunts and uncles, etc., etc. Okay? Okay, families contain elements. Families contain elements with, similar, cross that out, similar chemical properties. Okay, so the elements in a family all have the same number of electrons in their outermost shell called, what's that word again? Valence electrons. So if you have any, valence means outermost, right? So if you have like windows in your living room, I'm assuming you do, and you might have drapes, and sometimes there's a bar that goes in front of the drapes to hide all of the mechanics, that's called a valence, okay? It's the outermost part of the window, okay? Same thing with an atom, valence electrons, outermost part of the atom, okay? So, what I want to show you, oh yes, so on our periodic table, so we know our periods are our rows, okay? And notice here that in the first row we only have 2 elements, okay? And that first shell can also only hold 2 electrons. Hydrogen has 1 valence electron, helium has another valence electron. It has 2, okay? In the second row, notice how there's 8 elements? Well, the second shell can also only hold 8 electrons, okay? So lithium has 1 valence electron, so it has this first shell is full, and then in the second shell it has 1 valence electron. Beryllium has 2, crossover, boron has 3, 4, 5, 6, 7, 8. So this is a really great tip on how to figure out valence electrons in an atom really quickly. Is you just start from the left side of the column, like left side of the periodic table, and count across until you hit your element, and that'll tell you how many valence electrons there are. So if I looked at sulfur here, I have 1, 2, 3, 4, 5, 6. Okay. If I looked at calcium, I would have 1, 2. What about oxygen? Oh no, sorry, what about nitrogen? 1, 2, 3, 4, 5. Okay, so you're just reading across, and that tells you how many valence electrons it is. That's an easy way to figure it out really quickly. Okay? Okay, turn the page. If you watched the Brain Pop video, and hopefully you did, it talked about the families and some important traits, and we need to know these when we're talking about bonding and what's going to happen. So if you haven't watched that video, please go back and watch it. You can pause this and then go watch it and then come back. Okay, so we talked about alkali metals. Okay. Actually, I'm just going to pause here. We'll stop this video and then we'll start a new one.